I'm going to be talking to you about why science is done for the sake of science itself. But I think this is best approached by looking at the history of science. I'll take a couple of examples. Just imagine that in the 17th century, there was a businessman in Holland, the Netherlands. His name was Antony van Leeuwenhoek, and he was actually in the business of selling textiles. And since he was in the business of selling textiles, he would like to examine the cloth very carefully, and therefore he was using magnifying glasses. Magnifying glasses were known at that time. He then decided that he would like to have higher and higher magnification. And he learnt how to blow glass, and once he learnt how to blow glass, he made his own lenses, and once he had his own lenses, he was on the way to making his own microscope. Although microscopes had been invented at that time, they did not have very high magnification. But Leeuwenhoek's microscope had a magnification of almost 200 times, and therefore he now produced this instrument with which he could look at nature. But what was remarkable about Leeuwenhoek, he had no formal training in science, but once he had an instrument in his hand, he now began to look. He looked at everything under the microscope, and one of the first things that he looked under the microscope was a drop of water. And when he looked at the drop of water, he found that in the water there were hundreds upon thousands of small wriggling entities. These were microorganisms, bacteria which he could now see under the microscope. What had Leeuwenhoek achieved? He'd now actually discovered an entirely new universe, the universe of microbiology. Around the same time, Galileo was beginning to use the telescope, and when he pointed the telescope to the skies, what did he see? He saw many things that you had never seen before with the naked eye, and therefore he actually began now the exploration of the skies, the stars, in fact of the universe itself. So you can see that astronomy and astrophysics might have been born in the time of Galileo. Microbiology might have been born in the time of Leeuwenhoek, both of these in the 17th century. Now, neither of them was in fact wanting to do science because there would be something achieved by doing science. They were in fact merely examining nature around them, and in this process they discovered two universes which were unknown to ordinary people at that time. Remember that this was also around the same time that Newton was beginning to think about gravity. And it is Newton's thinking about gravity which eventually led to the kind of mathematics that we use so commonly. Calculus itself is because of Newton's thinking about mechanics, about motion, about objects moving. And therefore you can see that in the historical development of science, there's always been a connection to the real world. We can move a little bit ahead. We can go all the way to the 19th century. And if you go to the 19th century and ask what might have been the major developments that might have happened at that time, there was this remarkable experiment that Faraday did. He performed this experiment in the Royal Institution, where he showed that electric fields and magnetic fields were in fact connected to one another. Today this is an experiment that is done in schools, where children show that if you have a current moving in a circular coil, you can have a deflection on a magnet, or if you have a magnet moving around, you can create a current in a coil. This connection between electricity and magnetism was demonstrated by Faraday in this famous experiment. I must tell you a story here. Science sometimes has influenced society in many ways. Now, for example, if you are in a city like Bangalore or in a city like Mumbai, you will find that many streets are one-way streets. Because the traffic has become so intense, you cannot now drive both ways in a single street. You can now ask a question, and sometimes children might actually ask this question: which was the first one-way street in the world? And the very first one-way street in the world was the street in front of the Royal Institution in London. And this was because when Faraday did his experiments on science, who came to listen to Faraday? They were all the Victorian ladies, and the Victorian ladies would be well dressed, they would come in horse-drawn carriages, they would not walk great distances, and therefore they would come with their carriages right up to the entrance of the Royal Institution and park their carriages there. After a little while, the entire street was blocked because of this demonstration of science, and the local municipality then declared it as a one-way street. So science has in fact been responsible for the first traffic jam in the world. And this, I think, tells you that science can sometimes be done for science's sake itself. You're all now teachers of undergraduate science. I'll take another 19th century example. The young Pasteur did a very famous experiment in Paris. He took the substance tartaric acid, dissolved it, and crystallized tartaric acid. And then when he crystallized tartaric acid, he got crystals which he examined under the microscope. By this time, over 100 years after Leeuwenhoek, the microscope had developed quite a lot, and he could see his crystals very well. And he noticed that if he looked at one set of crystals, the faces of the crystals, and you should look at sugar crystals and other crystals carefully, if you looked at the faces of the crystals, he found two kinds of crystals. They were mirror images of one another. It looked like if you took one and reflected through a mirror, you would see the other one. So once he had these two mirror image crystals, he separated them physically into two piles, one which were left-handed crystals and the other which were right-handed crystals. Much the same way, if I had a lot of gloves, I can separate them into left gloves and right gloves, or if I had shoes, I can separate them into left shoes and right shoes. Having done this, it was known at that time that if you took a crystalline substance like quartz and you passed polarized light through a quartz crystal, the plane of polarization was rotated. So there was optical rotation when you passed polarized light through a crystal. But what Pasteur showed was that if you took these crystals and dissolved them and you got a clear solution, and you passed polarized light through the left solution of left crystals, the plane of polarized light was rotated in one direction, and if you did that with a solution formed with the right crystals, it was rotated in the other direction. What had Pasteur demonstrated? He had now demonstrated that molecules, individual molecules, can be asymmetric, can be chiral in the words of Lord Kelvin, and that they can now rotate the plane of polarized light. By doing this, Pasteur really started the field of organic stereochemistry, and in fact all of biological chemistry, biochemistry rests on the principles of stereochemistry. So he is in many ways the founding father of stereochemistry. He is also the founding father of microbiology in many ways, because Pasteur demonstrated the connection between microorganisms and disease, and it is because of that that he also decided that microorganisms were no longer infectious if you boiled them or you sterilized media, and as a consequence we have now given the name pasteurization to the process by which milk is made sterile. So science sometimes is done purely to understand nature, and when one understands nature, every now and then you find a wonderful spin-off which results in a practical application. This fact that science must be done for the sake of science is not understood usually by politicians, it is not understood by administrators, and unfortunately many times it is also not understood by teachers of science. We can go to the 20th century now. If you go to the 20th century, you can ask, can we now look at some examples where science has been done for the sake of science in India and which has now produced wonderful results? The very first example of science just to study nature was done by Jagdish Chandra Bose, J.C. Bose in Kolkata. What did Bose do? Bose did many things. Bose in fact is the father of wireless telephony. He in fact discovered this slightly before Marconi, but never did quite get the credit for it. But Bose did something else which was very interesting, which people at that time thought was completely nonsensical. He felt that plants were living and plants would respond to external stimuli. So he would in fact play music to plants and ask the question, did they grow better? But he also did some other very interesting experiments. He applied electrical stimuli to plants and then showed that the electrical stimuli when applied to plants did have an effect on the behavior of plants themselves. There were physical effects which could be observed. Nobody believed him at that time, but later these experiments in plant physiology were in fact reproduced in London, and subsequently I think in the modern era these experiments do have a sound scientific explanation, because in all living organisms cells respond to electrical stimuli. Communication in biology is very often through chemicals or through electrical signals like in the brain or in the neuromuscular junction. The last example that I would really like to tell you, which is of historical interest, is that of C.V. Raman. Raman, you might ask, well, how did Raman get to studying the scattering of light? Raman studied the scattering of light simply because he was interested in natural phenomena. He was interested in the color of the sea, which he observed on a voyage when he was coming back from England. He observed that the Mediterranean Sea was wonderfully blue, and he asked the question, why is the Mediterranean Sea so blue? The sky is also blue. And Lord Rayleigh had suggested that what you were seeing was really a reflection of the sky, the sea. Raman realized that there must be another explanation. He then began to study the effect of light scattering and showed that the color of the sea was really due to the scattering of light by the molecules of water which are there in the sea. Rayleigh ironically had shown that the color of the sky was the scattering of light by molecules which are present in air, and therefore light scattering and molecules now became connected in Raman's mind. And he began to look at light scattering from all kinds of materials. And this is how he discovered one day that when you had organic liquids and you passed light from a mercury lamp through them and you observed at right angles, you then saw that the color of the scattered light was in fact different from the color of the incident light. So the wavelengths had changed, and where had the energy gone? The energy had gone into the vibrational levels of the molecule, and that was in fact the Raman effect. It was an effect in physics, but then became most important in chemistry. When Raman received the Nobel Prize, the Raman effect was considered as a wonderful experimental demonstration of the quantization of energy levels in molecules. On the other hand, the applications of the Raman effect are far beyond the study of molecules themselves. Today the Raman effect is used even to study the age of and the molecules which are present on the shroud of Turin, the cloth which is believed to be the burial cloth of Jesus Christ. So there are many investigations today which are done using the Raman scattering phenomena. In these examples, all taken from history, what I have actually done is to tell you that none of these examples, none of these investigations, none of these researchers were carried out by the scientists because they wanted to achieve something specific as an application. They were in fact interested in science for the sake of science itself. There are no better examples than our own scientists, Raman and Bose, whom I have talked about. But can science be useful? It can be. There is one very dramatic experiment done more than 100 years ago, right around the time, the end of the 19th century, when Roentgen discovered X-rays, when he was working with cathode ray tubes, and he discovered that he had produced this new radiation which produced an image on a fluorescent plate which had been placed some distance from the tube. He then called his wife into the room. He had a photographic plate on the other side, and asked his wife to put her hand before the tube. And so the rays which were coming out now projected onto the photographic plate the skeletal image of her hand. Roentgen's wife's reaction is worth recording. When she saw the image of her hand, this is what you see in an X-ray, she said, "I have seen death." And the physicists did not think very much of Roentgen's discovery, but the medical practitioners, when they saw this, immediately knew that here was a diagnostic tool. And so it is actually doctors who initially began to exploit X-rays. It is only after a decade or so that physicists began to exploit X-rays, when they showed that if you pass X-rays through crystals, you get diffraction. And it is X-ray diffraction which has allowed us to study molecules of very important biological molecules over the many years after the first diffraction experiments were done. But my last example is one from the time when I was a PhD student. One day at lunchtime, my professor came in and said that a friend of his who had been in the laboratory some years earlier had done an interesting experiment. This experiment was in the area of magnetic resonance. Magnetic resonance is a subject which is familiar to people in physics, and it is very widely used in chemistry. And the experiment that had been done was to take two tubes of water and then place these tubes of water in inhomogeneous magnetic fields and observe the magnetic resonance signals which come from the hydrogen atoms or the protons and the hydrogen nuclei of water molecules. And the image that was then produced in this experiment showed you that the two concentric tubes of water could now be imaged and projected onto a piece of paper, so that you could now show an image that you have two tubes. I heard this experiment as a PhD student. I did not know very much, and there were other more senior students, much more knowledgeable than me, who were in the audience, and all of us finally concluded that this experiment could have no possible application whatsoever. But it turns out that this experiment, called zeugmatography, was the first experiment which in fact demonstrated magnetic resonance imaging. And today, if you have headaches over a period of time, you will be asked to go and get an MRI scan. Sportsmen get MRI scans every time they have a pain in one limb or the other. And MRI scans are available in all our cities and even in our smaller towns now. And if you can ask, where did this diagnostic technique develop? It developed from this original experiment of trying to image two coaxial tubes of water. I do not think Paul Lauterbur, who did the original experiment and received the Nobel Prize many years later, imagined at the time that he did this experiment that it would one day be used to image every part of the human body. So these are all examples which tell you that it is important to pursue science for science sake. Science is an extraordinarily exciting activity. It is not given to every scientist to make a major discovery, but unless many scientists keep trying to make discoveries or try to understand nature, will there ever be a chance of making a major discovery? You must remember that doing experiments is a very important part of science, and thinking about the experiments or thinking about what you observe in nature is also a very important part of science. And I would like to just leave you with this one thought, as to why one should go on working. One should go on working because if you keep on working, the mind is prepared to make observations and to make conclusions from those observations. Remember that Pasteur's famous dictum really states this, that chance favors the prepared mind. So if you want to be lucky, what one needs to do is to keep on working. Thank you very much.